Hello, I'd like to show you now some basic about creating elements and nodes with Stiff3D. What I want to show you is how to create this structure, what you see here, with a column in Z direction, attached two beams in Y and X direction here, in the plane, at the roof plane, the top plane of our structure. That's what we'd like to create. And let's do that completely from scratch so we can see everything what is of importance. To go to scratch, we clear everything what we see, so clear all, we confirm, and we are left with the completely empty GUI. Then we would like to start to create something, and we go to create. And Stiff reminds us that we have to think about all of this relevant parameters, in particular the outer box of our structure where everything would be embedded. I would like to create an outer box of side length 12, and to make it symmetric, that means in X direction it should run from -6 our outer box to +6, and from -6 to +6 regarding Y, and as well as also for the Z direction. Next, we have to decide about the distances of our grid, so the distance between these points, what you see here, and think 1 is just a reasonable idea. Let's keep it with 1. Eventually we can give a name here, stiff example number 1, or what you like as a name for your example. There we are. Okay. So now we are ready to input something, and what would you like to start with? Let's start with nodes. Create nodes. I give a double click, because I would like to determine more than one node. Let's start with the XY plane of the top. I go to -3, -3, X and Y, and we can just check here looking at these two cells at the bottom. As you see, as they're moving around the cursor, the respective coordinates just show up. And if we go here in the XY view, you see we can just take a look at the X and the Y coordinates. So since the grid is put on, the values of the coordinates are just hopping with the difference of 1. That's exactly what we have selected. If I put off the grid here top right here, then you see the values are just be modified continuously as we just are moving the cursor. That's what we don't like to have. We put on the grid, that's why you have it. And I would just start with X equal to -3, Y equal to -3 here at the top left. So that will be our first node. Then I would like to create the first element. Then we can do that by switching to creating an element, making use of the node what we already have, and just moving the cursor to the second node, which I would like to have at X equal to 3 and Y equal to -3. That will be the second node of the first element. And as we just confirm this selection, you see the respective element context menu just pops up, and we have to give the first time respective values for material and cross-section, the stiffnesses, bending and longitudinal stiffness, the torsional stiffness, and eventually if you like to give some line loads, you can do that here as well. So these are the numbers which we give for the first element, and that we just take as the standard. That means every other element which we now create will just take over exactly this value. Okay, and you see the first element is just created. We have another possibility to create elements that is more convenient if you are expert, and that comes together with the node creation option. I select node with double click, and the second element I will create by, again, pushing the first node where this element should start. Now I would like to create the element in the Y direction, and then I press the control button on your keyboard. While I press this control button, you see we can also create element in the node creation option. If I just release this key, the control key, you see we are back here simply with the creation of nodes. Again, I press the control button, and as I've just moved the cursor, you see we just are able now to create an element as well. So 1, 2, 3, 4, 5, 6. That's exactly the length of the element I would like to have. We can also check at the bottom left here the coordinates of this node. Pressing the left cursor mouse button, we just confirm the generation of that node. As you see, we have now created 2 bars in a plane with the same z coordinate parallel to x and y direction. That's exactly the top of what we would like to have. You may ask, what was the selection for the z coordinate? Every node has 3 coordinates, x, y, and z. What was the automatic selection? And this automatic selection, that is with respect to this hair cross, what you see here. I just selected the hair cross. And this hair cross, that's what we call the design node, that gives us the missing coordinate if we are generating a node here in one of these views, x, y, and the other guys. So pressing here in the xy plane, somewhere and generating a node creates a node with the z coordinate of the respective crosshair design node. So here x and y we select by pressing the button, and automatically we receive the respective z value, quite obviously. Let's take away this node here again, we delete it, so it's away. So also here, if I just press here somewhere and you create a node here, so the respective x coordinate, which is missing here of course in this view, is exactly that one, what we see with the respective value of this crosshair. Okay, let's check it. I create a node here, and you see this node with the respective y and z coordinates, just by selection with the cursor, receives automatically the value of this crosshair. And that's exactly how we can just create nodes on a respective level. And that means creating a node here on level somewhere below. We simply shift the crosshair to there. I create a node, and you see this node with the coordinates x equal to 5, y equal to 2 receives automatically the z coordinate 4. That's exactly the idea of this crosshair design node, as we call it. Just by moving this around, how do we move something? We select it, release the left button of the mouse, then we press again, and then we can just move this object to somewhere where we like to have it. That's exactly how we can do that. Good. So to come back to our structure, so we have now the top 2 bars. I would like to create the column, and then we come to the specific definition of the z coordinate here in Stiff. That's related to our lectures where forever, let's say since ever, the z coordinate is pointing downward in our lectures along gravity. So at the roof of the structure, the z has a smaller value than at the bottom, at the foundation. So, and to create the z aligned column pointing downward, so we should attach that here to the cross point there. That's exactly here. Perhaps we do it here now, and I would like to create element. I select the node, I press Control button, and just move the cursor, and you see we fail to find here the point with the coordinate z equal to 6. That means we have to move everything a little bit upright. So that was not what we wanted to. I just select it again, go to the right hand mouse button and delete the selection and put it away. Okay, so that means we have to move everything a little bit upright in that direction. How can we do that? That we do if we just go with the cursor in the back, go to move, and we just move our view enough upright that everything will be okay. So to create this column here, this column, this column downward. So, and what we're doing here, we're now watching, we just are in this view Y and Z. That means we're watching from the left to the right here at what would be looking there. That means we would like to arrange a node, with this collected below this node in the proper distance. That means we have to adapt the respective x coordinate to 0, and that we can do in this view here. We just align the crosshair so that we can just directly control the x coordinates. So the new node what we will create will have the x coordinate x. So, and we would like to have it just 6 values below this top node, 1, 2, 3, 4, 5, 6. And there we are. So you see we have created now this little structure, with these two horizontal bars in the roof plane, and we have the column also of length 6. I move also this view a little bit so we can see it better. So that's exactly our structure. And then we would like to have a fixed foundation here. So we select this node here, conveniently here in the 3D view, and we just go to over there and just select the complete clamped foundation here. If that is too large, these symbols, we go to options, go to node, perhaps eventually just make it a little bit smaller, the support scaling, so that looks better. That's it. So then we can save everything what we did. And that means we can go on after saving that to make sure that we don't lose anything. But if we are completely satisfied with everything what we have, we can do save and quit, and may take a look into the result of our operations. So looking at the table for the nodes, you see the 4 nodes what we created. With the respective coordinates. Here you see the foot, the foundation here at z equal to 6, z equal to 0. These are the 3 nodes in the roof plane. Then we have the system with the topology for the 3 elements running from node 1 to 2, 3, and 4. The respective lengths and the respective choices for the stiffnesses. So what we didn't care about was the arrangement of the local axes. The local axes are arranged such that the x-axis is running along the bars, and the y and the z-axis are just spanning the cross-section respectively. Okay, that was the principal ideas of generating elements and nodes. And it's now left to you, just to make for exercises. And I just tell you, playing around with this crosshair, the design node, that is essential with respect to creating the missing third coordinate for any of these views. And with some experience, you will also become an expert in that regard. Thank you.